Hello everyone, welcome to my talk on personality traits recognition in online social networks. I'm Pavan Kumar and I'm a master's student at the University of Calgary, and this research was carried out with the supervision of my professor, Dr. Marina Gavrilova, and we are from the Biometric Technologies Lab in our University of Calgary. Okay, so in our talk today, I'll identify the problem that we are trying to solve with our research. The application of personality traits information in cybersecurity. I'll also briefly lay out our research goals and the contributions that our work makes to this field. And I'll also discuss some of the related work and then lay out the methodology that we proposed and the experimental results that our research gave, and then the conclusion with some future works. Okay, so recognizing author identity from the text or information available on social media is of keen interest to security researchers as well as government agencies. We have seen that users are revealing their personality traits on their social media usage via their content that they share, as well as the text that they use and the language that they use on social media. So there is emerging research potential to use existing natural language processing techniques to analyze social network activity. And in our work, we are trying to predict the user's personality traits from their Twitter profiles and the text that they reveal through those Twitter profiles across two different dimensions, which is the MBTI or the Myers-Briggs type indicator and the Big Five personality traits. Okay, so what are personality traits? To answer that question, we have to see what factors control a user's or a person's behavioral aspect, right? So psychological research has revealed that 5 different factors may be used to represent the different aspects of a personality of a given user or a person. So this is openness to new experiences, which is part of the Big Five personality traits, conscientiousness, which is orderliness and dutifulness, then introversion or extroversion, then agreeableness, which is how they negotiate for themselves or for others, and neuroticism, which is susceptibility to emotional responses. So this is the Big Five personality traits, which is one scale. The other scale is the MBTI model that has been used extensively throughout our psychological study. So MBTI tries to use similar dimensions, but it has 4 different dimensions that describe a person's personality traits. So which is the intuition or sensing, extroversion or introversion, and feeling or thinking, and judgment or perception, right? So they have shown some correlation with the Big Five personality traits as well. So for example, the first dimension, the intuition and sensing, is related with the openness to experience. Introversion, extroversion is correlated with the extroversion trait using the Big Five. And agreeableness and conscientiousness feed into our feeling and thinking dimension, and judgment and perception is related to the conscientiousness dimension on the Big Five. Okay, so what is the application to cybersecurity? So personality traits have shown to have a strong correlation with user behavior. So this can be in the context of their behavior intentions, their impulsivity, and their susceptibility to cyber attack victimization, right? So actively and passively predicting their personality traits from the footprints that they leave on social media is a alternative to surveys in the case of organizations, and it can also inform the security design that they make for their security systems. Okay, so in our work, we try to use the tweets or the information available via tweets. And in a way, we use the static word embedding, which is the TF-IDF, or the term frequency and inverse document frequency metric, which is based on frequency of the words that occur in the corpus. And the glove vector embedding, which is a distributed representation of words, which is based on co-occurrence of different words. And we also use the emerging NLP model or the language model called Universal Sentence Encoder, which can encode sentences into vector representations based on the context of the language that they use. So this incorporates all the different types of language that people use on Twitter. So it incorporates the context as well. And along with that, we use stylistic features, which are patterns in user texts which are not related to the text itself. So for example, the number of ellipses or exclamation points or question marks, and the number of URLs or mentions or hashtags that users reveal. So all of these are considered as stylistic features. So we propose these three different feature sets to represent tweets in a manner which can be used by a classification algorithm to reveal or to predict their latent personality traits. So that is our first goal. And the second goal is that we can capture the patterns that emerge through the stylistic features, such as the patterns in the URLs, mentions, hashtags, etc. And the third goal is to combine these distinct feature sets in a way that can be used for feature reduction as well as input to our classification algorithm. So with our work contributes in a way so that we can combine distinct feature sets into a compressed representation using genetic algorithm. And the ensemble classifier that we propose is validated on 2 publicly available data sets, and they outperform all the state-of-the-art systems. And the reusability of our feature extraction, classifier training, and performance evaluation is standardized for reuse of this work for future works as well. So we use the Twitter MBTI personality traits dataset, which was collected by Personality Cafe and made available on Kaggle. And for the Big 5 personality traits, we use the PAN 2015 author profiling dataset. Okay, so some of the works which aim towards the same goal, that is to extract a person's personality traits using Twitter or data available on Twitter. So Kersia et al. Kind of got the ball rolling with this research. So they used the follower or the user's following and the listed counts to predict the personality traits. Liu and Perez used atomic character representations and then hierarchically built word representation from those character representations and then sentence representations using those word representations. And they used a deep learning model. And they were able to achieve a mean average accuracy of 0.12 for predicting Big 5 personality traits. And the latest work, which uses a large data set of users, was by Arno et al., which used the glove vector embedding along with applied Gaussian process regression to achieve a mean average accuracy or a mean average error of 0.1 to 0.15 across the 5 dimensions. So for our language, so in our proposed language-based feature extraction, we use the tweets from a user as the text or the information that we're trying to use for our classification. So each word is converted to a vector format. So for that, we use one of the frequency-based term, which is TF-IDF, which is calculated for each word within a tweet. And along with that, we use the 100-dimensional glove vector representation, which extracts the vector or real valued vector representation from words using co-occurrence statistics. So we use the weighted representation of TF-IDF, which captures the frequency along with the co-occurrence. So this too is weighted. So the most important or most descriptive terms within a tweet are given more weight, and their distributed representation is used to calculate the vector representation of a single tweet. Okay, so we can take the word representation across the tweet and then find the average or the mean across all the words to get the representation for a tweet. So for the sentence representation, we use the universal sentence encoder. So for that, if we get two sentences or more than, like, for example, if you have two sentences within a tweet, we say A and B, which have both N words and K words respectively. We combine the sentence representation as shown here, which will allow us to calculate the overall representation of the tweet, which can be used as input to our classification. So for our stylistic features, we represent the non-verbal indicators such of emotion, such as the mentions that users make, the number of words within a tweet, or the number of URLs, average number of URLs, or average number of ellipses, exclamation marks, and question marks. So these are considered as descriptive of emotion within our research domain. So we use all these three features. So to combine these distinct feature sets, so for example, the frequency-based, co-occurrence-based, and context-based, as well as the stylistic features, we experimented with different feature reduction techniques such as PCA, LDA, independent components analysis, as well as genetic algorithm. And it revealed that genetic algorithm is able to combine the distinct feature sets in the best possible manner. So for using genetic algorithm, we use individual dimensions of our concatenated vectors to as genes, and like the individual dimension or the feature is considered as a gene, and the final building block will be the chromosome, and each gene is either selected in the final chromosome or not selected, which is like a binary choice, or 0 and 1. So we iteratively build the chromosome representation from our existing gene pool and try to find the best combination of features which will give us the maximum accuracy with minimum number of features. So our Linguo-stylistic based personality traits assessment system, or the LPTA system, is shown here. So as mentioned, we from each tweet, we extract only the words by removing the URLs, emojis, and mentions, which will be used by our stylistic feature module. So before that, we calculate the TF-IDF and the glove representation, and we calculate the weighted glove embedding, and we get the universal sentence encoder representation from the USE model. And these two are considered as language-based features. And for stylistic features, we use the average word length, average hashtags per tweet, average emoticons per tweet, average mentions, URLs, ellipses, exclamation marks, and question marks. So all of these are considered as distinct feature sets, and they are concatenated with the language-based features and fed as input to our genetic algorithm. So in our genetic algorithm, we calculate for 80 generations. We iteratively select or not select different features, and they are fed into our ensemble classifier to predict the overall accuracy. So if a selected set of features gives increased accuracy, then we use that in our future generation, and the generations which don't give good accuracy are discarded. So we split the data into training and test set for this methodology, and in the end, we receive our final compressed input representation, and which will be used for further testing. So for the classification, we tried different machine learning models, such as Gaussian regression and SVM, XGBoost, and other machine learning models as well. But we found that the linear SVM and XGBoost model gave us the best result. So we chose those two as part of our ensemble method. So for the data set, we use for MBTI personality traits, or the 4-dimensional personality traits, we use the Twitter MBTI data, which was collected by Personality Cafe Forum and made available on Kaggle. So this has data from 8,675 users, and each of them have 50 tweets per user. And on each row, we have the 4-letter MBTI representation. And for the big 5 personality traits, we use the PAN 2015 author profiling dataset. for training, which has data from 152 users and 200 tweets per user. So we first train on the MBTI, which has more data, and then also use the same representation which we receive from our genetic algorithm for our big five personality traits. So when we performed the experiments and compared with the state of the art, we have shown the results here. So for MBTI, or the four-dimension personality traits, we treat it as a binary classification problem across each of the dimensions. So basically we have four classification that goes on for each user, and it predicts whether it's whether they are extroverted or introverted. So it's like a binary classification problem. And same thing for across the four dimensions. And for the big five personality traits, the data set has labels from minus 0.5 to 0.5 for each dimension, which we use the mean absolute error and root mean square error as the performance metrics. So for the big MBTI personality traits, our model was able to increase the accuracy of the introversion extroversion dimension by 8.7%. So we are just reporting the best result here. So it gave better accuracy across all the dimensions, but the biggest increase was across the I and E dimension, which is the introverted extroverted dimension, and that was 8.7% in terms of accuracy and 22.5% in terms of F-score. So F-score was the best. Previous was 0.71, and we were able to get it up to 0.87. And for the big five personality traits, we were able to improve the mean average error and root mean square error across all the five dimensions. When we try to see the reliability of our model, we try to calculate the area under the curve graph. So we see on the left-hand side the Twitter MBTI graph, for which we were able to get the AUC of 0.78 on an average across all the dimensions. So that shows that we have some reliability. And for the big five personality traits, we see that the reliability is different for different dimension. And the best was for openness and then like introversion, extroversion dimension. But the average AUC or the micro average AUC was similar to the one in MBTI. So this can be attributed to the reduced number of users, as well as the increased number of dimensions that we need to classify upon. So for the genetic algorithm, we found through empirical method that using 30% of the features gave us the best result. As in increasing the number of features did not give that much increase in our performance. So we chose 30% as the fraction of features used. And we performed the genetic algorithm across multiple generations. And we didn't see any significant increase after the 80th generation. So we use that as our hyperparameter. So with our work, we were able to reveal that users' personality traits can be discerned from the linguo-stylistic cues that they make available on Twitter. So we also introduced the frequency, co-occurrence, and context-based language features and how to combine them. And also we found the novel set of stylistic features which we use in our model. And the future work will be towards trying to use this passively assessed personality traits for user recognition. So this work was published in the Advances in Video and Signal-Based Surveillance conference, and a expanded version is also submitted to the Transactions in Computational Social Sciences journal, and it's awaiting publication. So these were the references to some of the most important literature that we use in our work. So that was the MBTI personality traits, as well as the PAN dataset. Along with that, we found different works which talk about the different language-based features that they use. So Kersia et al. And Russell et al. Talk about a different set of features to be used. And Arno et al. Talks about using only 25 tweets to calculate this personality traits. So that's it for the presentation. And if you have any questions, we have a Q&A session. And this is our email for our research lab. So thank you. Thank you for joining me.